Hey, what's up, guys? I'm back with my new video on the SQL series, and today we will be discussing about the right joins. Uh, in the previous videos, we have been discussing about the inner join, left join, and the basic SQL select syntax uh, about the where clause and the group by clause. So let's move on to the right join. So I have connected to the database. Adventure works. So there are a few tables that we will be querying. So let's look some of the tables. So on the Adventure Works database, we have three of the tables that we will be using here uh, related to the product. So production dot one is production dot product. Just I will select top 10 rows, might be, just to have a glimpse of the data we have. So we have product ID, name, and the product number and all those fields. uh, we have here product subcategory. So this is null for the columns for some of the rows here. So but it would be some value for product subcategory is not null. For some of the products it will be some value. So let's check. So yeah, so these subcategory IDs are the foreign key stored to denote the subcategories that are listed on some other table, which is again top 10 star production dot product subcategory. Okay, so the product belongs to some subcategory, and these are some of the categories here, and these are linked to a product category. Okay, okay, so these are the four categories we have in the system. Okay, so this is the hierarchy where we have the category, then subcategory, and according to the subcategory we will add the product. So let's make a join of these three tables and get the product details. So how will we make a join? So what we're gonna do here is first let's pick this one, since this is the parent. Traversing through this one is much better way. So I will do an inner join of category with the subcategory table. Let's give an alias for this, PC product category and PSC for product subcategory. So PC dot product category will be PSC dot category and this table. So again, now let's make another join without selecting the data. Product dot product P on P dot subcategory ID. Okay, and PSC dot subcategory. So for if we want to pick some of the products for some category, we cannot make a direct join, we need this subcategory in between, because the product is directly linked to this subcategory. Okay, so let's just view some of the select star would basically pick all the columns from these three tables. What we could do is, so we don't have to scroll, what we can do is product category dot name and product subcategory dot name and product dot name. Okay, then maybe we just want to see other fields from the product table. So now let's select them. Okay, so I renamed those columns. So one is the category, second is the subcategory, and third one is the name of the product. So now so suppose we have a requirement where we want to fetch all the products, but provided we first of all need all those products with with some category, and then those products for which we don't have any subcategory ID. Okay, so what we want here is, let's just see whether we have any product where the subcategory is null. So we can see here that there are almost 209 rows where the subcategory is null. So now we want a query where we want to get all the records, but the ones which have some category should be shown up, and the ones which are not categorized will be shown after it. So how can we do that? So definitely we have to change the query here. First of all, what we have done here is the inner join. Obviously you have to change this inner join of product with the product subcategory and make it a right join, because the inner join will only work when the subcategory is present on both the tables for the rows. So if the product having the product subcategory ID is as null, will not fetch the rows from the subcategory. So in that case, that product will not appear in our results. So we will use the right join here. So how will this right join work? So right join says that it will basically return all the rows from the right table, and it will return all matched rows from the left side. So it will return basically all the rows from the right side and from the left side. So suppose we have 3 or 4 joins here before the right, so all the rows that are returned from that joins will be matched against this right table, and if they are matched, then they will be joined with this rows, right table rows. And for the rows for which we don't have any data on the left side, then on the left side columns we will have the null values. Okay, so let's just query, then it might be clear. So this time if I just run, so we can see there are 504 rows, and we are also fetching the product which doesn't have subcategory or a category. Now the user wants to order the data on basis of category, on basis of having categorized first, and then the products which are not categorized. So we can either say subcategory descending, but this would actually change whole of the order. We can make another expression like case when um, subcategory um, product subcategory is null, then rank it as 2, else rank the value as 1. Now if I just run the query, okay, now I think there is an incorrect syntax near the keyword inner. I think this should work now. Let me see. Okay, so it works fine, and now you can also order that by subcategory or a category. So let's have that ordered by category and then subcategory. Okay, so this is how we're gonna show the data. Now you might be thinking, is this the only way we could get the data? No. So we might use left join as well. So the idea behind writing this query was to show how the right join works, but this whole query can be also written can also be written using the left join, and it is so the right join is can be used when we have a lot of queries from, and suppose like here we just have 2 tables that are joined, but there can be 10 to 15 tables that are joined, and you don't want to change the order of their joins, and you just wanted to add your logic. And in that case, maybe you want to fetch all the records from your side, and only the match data that is coming from the left side you want to show them. So in that case, right join can be helpful. Otherwise, you can also turn this into a left join if you make this right table at the very top of the hierarchy, where you used from statement. You could just use this one and make a left join. So in that case also this should work. So let's convert this query also to left. So what we can do is select star from production product on left join on production dot product subcategory, and this should be on the okay. Now make another left join because whatever the results have been fetched from the left side, you want to keep that result and you don't want to lose that. So again, production dot product category on psc dot category id category. So this is how you make a left join, and now you can just say the same thing what you did here. Order by where psc dot subcategory is null, and you can just select the same columns here. And see, you could write the same query using the left join. So okay, so let's make one more query here. Suppose we have a product okay. So we don't have any description here, and there is a column so there is a table production.culture, and this would have all the languages that our table supports, our system supports, and we want to just add a description for a single product, and we want to do that on all languages, and we might have to insert that into some another table. So suppose I have a temporary table here. In the SQL server, we can make a temporary table using the single hash or a double hash as well. Since this is a temp table, I won't add much columns here, just one column for the description. One column would be for the culture ID, which is again a varchar, and this is, let's make it 10, and then an ID for the product. So it is, the ID is an integer, so we can just write this thing. So I have created this table. We can see we don't have any rows. Now what we're gonna do here is for a single product, suppose for this adjustable race, I want to insert the data in this temp table for all the cultures that we have here. But first of all, even though we don't have any description right now, how can we make an entry in just one query for all the cultures in this? Do we know any sort of joins that we can use here? So we could use cross join here. If I just select product with the culture and where you have to write cross join, but in some of the databases you don't need even the cross join as well. Where product id equals to 1. So for only product id 1 I want to have all the descriptions here. So what we can do, product id, maybe we wanted to add some more information, then also we can do that, but for now suppose we have product id, and now what we can do is culture id. So you can see that for one product id 1 it has created 8 rows, and I can just say insert into temp culture test. Okay, so now we can see that the table have this values. So cross join can be used in a scenario where we want to insert a data with a lot of permutation combinations of the tables. So here we have one table and here we have another table, and we just wanted to have each of these rows for each of the entry of these product. Since I have just added here this clause, so that is just working for this one, and I believe SQL Server also supports this comma operator also for this cross join. Now even if we don't write cross join, this means it is a cross join. Okay, so if we just remove this one, we can see here 4032 rows, and this is actually 8 into the number of rows we have in the product table. So this is all about cross join. So these are the joins we have in this SQL. Definitely we could also make a join, self join on the table itself, and it can be used using this cross join or maybe inner left or right join, but these are the only joins that we have. So thank you.